So this is the integral. So from the minimum value up to the maximum value, which represent all possible values. So if we consider them together, so this is like the total probability, the probability for any possible values. Then the probability become 1. But the probability for any given value is 0. Maybe it's hard to understand, but because it's integral like the area. If we only, what's the area of a land? For a land, there's no area. So this is exactly the mean here. If we consider a given value, so the probability is 0. So for the continuous distribution, we cannot talk about, well, you can, but the probability is 0. You can talk about the probability to have the random value equal to 2 or equal to 3. They are always 0. So it makes sense if we talk about the probability in an interval, the interval from 0 to 1 or 0.5 to 0.2. So this makes sense. So talk about the probability like this. We give a range or an interval. So this is called an interval. Okay, so we just briefly mentioned some continuous distribution. So the simplest one is a uniform distribution. So which means one random number have equal chance to have any value from A to B. So we call that uniform. So for the uniform, we can find the density function. So this we call a density function. So the continuous distribution is so the probability we see before here become the density function. So this represented because it's not really a probability. Because the probability of a given point is 0. So we call that it's a density. So later maybe it's clear to you the normal distribution. So for any continuous distribution, we need to have a density function, and then we can fully, define continuous random number. So this is the exponential distribution. So it's common, like some, the left, the expect how many hours this letter can continue. So it's like this kind of distribution. So this distribution have the probability we call the lack of memory. So what does it mean? So this actually means if let's consider me and you. Well, I'm quite old. You are very young. But in theory, the probability I can live to next year, and the probability for you to live to next year is the same. It's still not easy to understand, but that's true. But that's based on theory. Even I'm 80 years old, you are 10 years old. So the probability for you to live 1 year more and for me to live 1 year more is the same. Okay. Oh. So, well, we consider that in a population level. So our probability is based on population level. It doesn't talk about one individual person. So if we are one member in a bigger population, that's true. So then basically that's on average. On average, if there are a lot of people who are 80, 100 years old, a lot of people who are 10 years old, so the probability is the same for both groups to live one more year. So sometimes I think there's a book called "Don't Be Cheated by Probability." If you because sometimes it's against our understanding. Let's say I don't know if you have the hobby to play some game. Okay, so I think in Australia there are a lot of machines. You insert some money, so the machine can turn. Suddenly, you can have a reward, but many times you will lose. Yeah. So let's say you play 1 hour. Let's say you play 1 hour, and then you are you're very much unlucky. So every time the machine turns out it didn't give you anything. So you may think, if I try again, I will have more chance to win a bigger money. Do you think like that?
Yes.
Yeah, it can happen. But, the probability for next time, whether you win or when you lose, is the same. So this again like the Binomial distribution. If I draw 10 chairs, well, the first 9 they are black. Maybe let's assume half. They are half. Do the consider let's consider half. Yeah, half. So all the first 9 they are black. And do you think the next time the 10 in the 10th drawing, you will have more chance to have a white?
Yes. Yes.
What? Who said that? Yes.
Black liquid.
Yeah.
When did you put them back?
No, I mean let's assume this is the infinity. So it doesn't matter. If you take a nine black, so the probability of black and white is still half and half. Okay. So I put a 9. But in this box, there's still half of white, half black. So how could the last draw you have more chance to get white? It's still same.
No, you can explain again.
Then you may be using the phone when you play some game.
No, you can explain again. So the probability of black and white
is half. I assume this is infinity. So if I draw 9 here, but the probability of black and white is still half to half, 50-50. And then you draw another one. But how could you have more chance to have white?
So for the first time, how many black and white you draw out?
No, after that is infinity.
Oh, okay.
Let's see. So this is like this one. It doesn't matter how long you have lived. Yeah. So the God is fair. So sometimes don't trust your intuition, right? We should trust the sense. We should trust the mathematician. But it can happen, next time you draw a white. But it doesn't mean, the probability you have white is higher than the probability you have black. Yeah, this again, like in about 30 years before in China, at that time every family is big. During my time, every family may have 5 or 7 children. Some family in China, sometimes, the man, is a power, they can do a lot of work. The some family, or they have first one girl, next one girl, next one girl, next one and girl, and suddenly they have a boy. But do you think, that after the four girls, the probability to have the boy is high? No, it's still the same. But they can easily be cheated, if you do some prediction, go to the family, wow, next one you will have a boy. And then that family will trust you like a god. But are you a god? So we should know, we are scientists, huh? Okay, normal distribution. So this is, if you forget everything, this is the only thing you shouldn't forget about the statistics. And also, you should remember this. You should be able to write it down after this course. It's hard. So here there's a pi, there's a e, there's a 1, but there's no zero, there's no I. It's the e exponential, yeah. So basically that's a Euler number. The e is come from Euler, the first name of Euler. It's yeah, I don't know. It's a 27. Well, the Excel, in your Excel, I think you just input xp. You will see the value of e. Pi here. You know what's the meaning of mu? Mu. What's the meaning? What's the meaning of mu? What? So there's another sigma square. Yeah. What's the meaning of sigma square? So this is the name of the distribution. So what does the n mean here? N? What does the n mean here? What does the n stand for? It's said here. It's said here. Normal. Okay. The p is a binomial. So the n is a normal distribution. So it's a normal distribution. So what does the mu mean? You didn't take any basic statistical course. The mu is called the mean of the population or the mean of the distribution. Sigma square is the variance. The mean and the variance are the two most important things. We cannot live with in statistics. The statistics mostly talk about the mean, talk about the variance. Why is it so important? So what can the mean tell us? Yeah, it's to tell the place of the distribution. If we have a variety, here have a given yield 100, but another one have 110. So that's the mean given yield. So it tells us the position of the distribution. So what can sigma square tell us? Yeah, it's how wide is the variation of that variable. So basically, this figure tells us 3 normal distribution all of them with the equal mean is 0, but different variance. So the larger the variance, so we will see, the value is more dispersed. So the smaller the variance, the random value is more, more concentrated around the mean. So basically, the normal distribution mu here represents the place of the peak. We can say this is the peak, is the peak position, and the variance tell us how big is the variation. So many times, this all the statistics talk about the mean, talk about the variance. If you do any experiment, I don't know what are you studying. For any biological study, you need to make some experiment. You need to have some treatment. So each treatment, actually, we can assume we have a normal distribution with a different mean. And most of the time, we assume the variance is the same because it's a random error. Okay, for the normal distribution, if the mean is equal to 0, variance is equal to 1, so there's a name for this normal distribution. They call the standardized the normal distribution. Because the mu equal to 0, sigma equal to 1, so this density function become much simple here. Then what's the probability? Now actually, if I know the probability, I know the density function, I can find any probability, for any interval. As I said before, don't talk about the probability at 1 point, or the probability, the random number is equal to 1 or equal to 0. But if I ask that, you should know the probability is 0. Okay. In the final test, you may be asked, to tell what's the probability for a normal distribution, normal random number have a value at 0 or value at 1. So that probability is always to be 0. So it makes more sense to talk about a range. So this table tells us, what's the probability for the random number between -1 and 1. So you can ask more questions about this normal distribution. So the probability for the normal random value number from -2 up to 2 is more than 95%. So if it's between 3, so the probability is about more than 99%. So these are the sum of the probabilities. So there are some other distribution which is more complicated, but well, don't laugh. That's the least she. The statistics about some inference. The inference we need to know the distribution of some samples. So the gamma distribution is a general case for the chi-square distribution. And another distribution is I think the beta distribution is a general case for the F distribution. Do you know F distribution? What does F stand for? F. How could I talk about the chi-square?
This one is for
F.
non-parametric. X square is for non-parametric and F.
So the chi. So these are the three. We call the three sampling distribution. Without this, again, there's no statistics. I said the summation. Without a normal distribution, no statistics. Without the 3, no statistics, because we cannot do the inference test. So without a normal distribution, there won't be the 3 sampling distribution. So the T actually also the represents the name of a person. Of course, here this I don't think represent any name. So whose name is this? Great. So actually, on the first class, I mentioned this. Fisher is the one who makes the greatest contribution to statistics. So he invented ANOVA. He invented the maximum likelihood estimation. He also made a great contribution to genetics, to population genetics, to quantitative genetics. You know the Mendelian. So you know the Mendelian law. What are the Mendelian laws? No. There are two Mendelian laws: the segregation and the independent dispersion. Yeah, at the end of this course, we will come back to some, to the Mendelian laws, because we'll talk about some genetic data analysis. So this is the first name of Fisher. So there's a person called his pen name is a student. He is I forgot the true name. He is a student of Pearson, who invented the correlation and regulation. William Sadly. Okay, great. I forgot. And his pen name is called just a student. When he published a paper on this distribution. But we will come back to this distribution next week. Of course, the distribution will be, something like this. You don't like. Well, I don't like that either. But sometimes we have to. We don't have a choice. So the distribution, as I said, for any random number, we have a distribution, and we have the probability. The probability actually is the integral. Or you can select that before I said as a cumulative. This density function like the probability, in the discrete variable. This probability like the accumulated. This like the integral like the accumulated. Or can be understood as the area and the if this is the normal distribution, and for any value here, let's say this mu. So the integral represents the area. Right? That's the calculus. And this is the px. So this is the area from minus minimum value to the px. So this integral actually tells us the area on the left of this line. Understand? Or like this. So this integral tells us. Okay, so I think there are some distribution, want to find the mean. It's how we find the mean of the variable. The mean is like the weighted average. The weighted, if without the p, so that's like a simple average. But each value, they don't have equal probability. So we take the probability as the weight. So there is a weighted average. We call the mean of the distribution. And for the continuous, this is the case for the continuous. So how about let's take a short break? Okay. Okay, let's go through a few more slides. Because this is also something very important in statistics. So first one is about for each distribution, we can find some we call the parameters. Parameters are about those distributions. So the first one is the mean. So it means the represent the mean of the the possible values of the random variable. So if this is a discrete distribution, if it's a continuous, of course we cannot do the summation. We have to do the integral. So there are some properties. If we talk about a constant number, of course the expectation is equal to itself. So if a random variable multiplied by a constant number, you can move the constant number before this the expectation. So for any two random number, so the two random number can be added. So the summation of the expectation is equal to the summation of the two expectations. So here the E is mean expectation. The expectation is it means the mean of the random variable. So the two random number can also do the multiplication. And the multiplication, it's not always can be written like this. Only when the two random number they are independent, so we can write like this. So the variance. So variance, as you said before, it measures the variation, how the how much variation included in the random number. So this is the definition of the variance. So again, it's an expectation. So this part can be, you can treat it as a deviation. So it's a deviation of each value with the mean, right? So this exactly, very same. Later, when we have the sample, we wanted to have the sample mean. We wanted to have the sample variance. So the principle is very similar. So this letter, when we find the sample variance, we need to find the deviation. So this deviation, and we make a square. Without the square, because some deviation is negative, some is positive, when we add them up, it becomes 0. So we make a square, and to make sure this is always positive. And this part we call the variance. For the two variables, we can also consider the covariance. From the covariance, we can have the correlation. So it's the covariance. So this is the deviation for the first one, deviation for the second one. We multiply them together, so have the correlation. If the two variables they are independent, which means there's no correlation. Correlation equal to 1. So the variance. So for the constant number is just the one value. There's no variation. So the variation equal to 0. So if a random number multiplied by a constant, so we can take the constant number before the variance, but we need to make a square. So the variance sometimes is called the second order statistics. Why we mean second order? Because it's squared. The mean sometimes we call the first order, but there's no square. But there are also some third order. Let's say the variance here we can put a 3 here, or we can put a 4 there. So that's here order. So if we put a 3 here, so it will measure the skewness. Last time we mentioned that every distribution will find mean, variance, or skewness, and the curves, right? So
Isn't the same?
same what?
Same.
Yeah. So here, if we put a 3, that also measures the skewness of the distribution. So here we talk about the distribution. So next week we talk about the sample data. So any distribution, well, it can, we can put a 3 here, we can put a 4 here. So that measure, the skewness and the curves of the distribution. Okay, so the covariance, form the covariance and the standard deviation. So the variance, if we make a square root, it's called the standard deviation. So form the covariance and the two standard deviation, we can find the correlation. So this again is a correlation of the two random variables. Of course, once we have 2 samples, we can also have the correlation. So basically, here we talk about the population parameters. Next time we talk about the sample. So here the population mean is similar to the sample mean. We are talking about the next week. The population variance similar to the sample variance. We are going to talk next week. Okay, and so for all the distribution that if we know the probability distribution or we know the density, we can find out the mean and find out the variance. I hope you can take take a look at this slide after the class. So it's about how to find the mean of the binomial distribution, how to find the variance of the binomial, and the Poisson distribution uniform, and the normal. So the normal is the look is easy, but to find the expectation is equal to mu, it takes several steps. So that's why here the mu we call the mean of the population, sigma square we call the variance of the normal distribution. So this gives you the proof. You always ask why. So this is why. Why the sigma square is the population variance. Okay, the gamma distribution and the beta distribution is more complicated. So this table gives the mean and the variance. I think you should remember. So for the 2-point of the Bernoulli distribution, the mean is P, variance is the PQ. Binomial is the NP and the NPQ. For the Poisson distribution, both the mean and the variance they are equal to lambda. And the uniform. So I don't ask that you remember everything here, but I ask you to remember this. No problem. No. Mean of the normal distribution is mu. Variance of normal distribution is sigma square. Don't forget. Okay. So next we will sit together to use the Excel to find some probability. So these are the names. Well, your first language is English, so you should official language. So basically means your English should be much better than me. You remember, uh, if you remember the name of the of those functions. So if we want to find the probability of binomial, we should use this function, the Poisson or exponential, and the normal distribution, gamma distribution. So all the distributions I know in statistics, you can easily find that in Excel. So this is not like when I was a student, there's no computer at all. There's a calculate. So when we do the exercise, we need to check the statistic table at the end of the textbook, to do the inference to find the probability. So now you are lucky, you have the Excel, give us most thing, we require to do the statistics. I think last week we draw these graphs, and today we will see more distributions. I also take you, to find the probability for this normal distribution. Mm-hmm. Okay, I will show you. Mm-hmm. Okay, I prepared this Excel so for you to know some basic calculus. You can do with the Excel. Let's go through one by one. Okay. So for the first formula, let's see. I remove this. Don't make this computer. Anyway, let's say I want to find the log function of one plus x. So here you input equal, and then you input the log, and you give a bracket. So and then you just input any number. Now I want the 1 plus x. So x is this column. So just that you can go to the cell and then you click. So actually this basically will give me the log 2, log 3, because 1 plus 1 is 2, 2 plus 1 is 3, and you can enter. So the good thing is for next one, you don't need to input that function. You just click. Once you see the plus, you drag it down. So immediately you will have this column for all the value of x. Okay. So this is the easy thing, in Excel many times. If you make a formula, you can use it in many places. You don't need to make the formula, every time. We find the mean. So basically in Excel there's no function called the mean. When you find the mean, you need to use average. So let's say I wanted to have I want to find the average of the 3 values, for each row. So I just click here and make the formula. Average. You see the average, there are many things, other things, when you know this, after the class, you can take a look at one by one. And also for each one, there's some message here. I think you all see some message. I see the message in Chinese. So and then the average you can select anything you want to find the average. Let's say this range from B2 up to D2. It's a computer, I don't like it. I'm online, so there are some machines don't put this D. So anyway, you just input the range from B2 to D2, and then you make a formula, and you just drag it down. So immediately you have the mean for every row. And if we want to find the mean of the column, you do the simulation average, you just select the whole column. So we will use this when we do the ANOVA. So the ANOVA always, we make a two-way table. We find the mean for each row, mean for each column. So basically, that's the first thing, to do the ANOVA. Can you follow? Okay. I think this up to now, everything should be easy. So this sheet about use the dollar. So before, when we move, everything move. Now sometimes we may want to fix something. Let's see the example here. So this column we find the mean and make it larger. And so this is the mean for the okay. This is like the total mean. So we make it. This. We have this like a two-way table. So we have the mean for each row and the mean for each column, which are given here. So this is the give another color. So this is the mean for each column. This is the mean for each row. Now let's say I want to find the difference between for the row. I want to find the difference of the this means to the overall mean. So this is like the overall. If you check the here, so that's the average of everything. So this is the over average. So I wanted to find the difference in this column. I wanted to put, the difference between these means and the overall mean. The overall mean, there's only one. So I wanted to fix it. So of course you can, if you don't know that, you need to, let's say, this difference is equal to E2 and minus at E12. And then you continue, for, and this one is different than this one. So if you don't, if you drag it down, you will see everything goes down. Because if you see here, when you drag it down, so this cell will come one down, this cell also come one down. That's not what we want. So there's a special thing in Excel, which is the dollar, the money. If you give money, you can do more things. So here we can fix it. I say we wanted to fix this cell. When we drag it down, only the first one move, but this one we want to fix it. How we do that? We give money. So we give $1. Let's say, actually here we give $1 is okay, but I'm rich. I give $2. Yeah. Because sometimes I don't, because the dollar can be before E and in the middle, so have a different meaning. Sometimes I'm confused. So I just give $2 at the first, and then I will see how to get $1 back. And then let's say if I drag it down, and then up here you see this cell is frozen. So the dollar means we can frozen that cell, and if you check anything else, it tell us only the difference between this mean with the overall mean. Understand? So in the ANOVA, we also need to do this quite often. So in ANOVA, actually, many times we need to find the deviation to the overall mean, and deviation, so we have to fix something. So let's see if we want to save $1. Yep. Let's say if I remove $1 here, what will happen? Yesterday I needed to. Do I have the same mean? No. So if I give we needed to give the dollar to the correct place. Otherwise, we cannot. Actually, here the dollar should be after E. Before the number. And then we have the same machine. So everywhere it's the difference before between this one and this one. So sometimes I'm confused. So I always try and then I know. So basically, if you put the dollar before the number, and if you move down, this cell will frozen. But if you move right, so this cell still moved. So later we'll see, we need to give the dollar in the correct place. Let's say you want to spend the money, you have to spend it, in the correct way. Okay, so for the for this deviation, I also want to find, the difference between, this means with the general mean. So I also make, make a formula here. I think I need to put the dollar. I just put, if I put $1, dollar should be before E, and then I drag. Okay, so here, if you go to the last column, last one, it gives us the difference between these two values. So the next, actually, we find the deviation by row, deviation by column, and now I want to find basically to find the difference between this value with this one, but take away the value here and take away the value here. Are you clear what we are going to do next? So next, actually, we want to find so first, if we make a difference between this value of the overall mean to in the ANOVA, that's like the total deviation. So this is the deviation for row, a deviation from column. The total deviation, I take away the row. This you can understand this as the row effect, column effect. Take away the row effect, take away the column effect. That's actually that's the residual effect. So how we do that? So I want to find for all there are 30 values. First, that I want the difference between the 30 values with the overall mean. And from there, I take away, the effect of row. I take away the effect of column. So there's a lazy way to do that. Of course, you can do that one by one. But or just see the formula here. So this formula. Actually, that's the